Live from Earth, it's Space Radio. This is Paul Sutter, and coming up, we're talking about, hey, look, it's a black hole. And of course, taking listener questions about all things in this beautiful universe, because that's exactly what this show is about. We record every Thursday at 4 p.m. Eastern. Don't call any phone numbers at all. Man, I've still got to break out of some old habits. You need to leave voicemails at our website at spaceradioshow.com and get your questions in. And in today's Blue Shift, I'll be talking about why bother with black holes in the first place. But first, the news. Hello, space fans. Welcome to Space Radio. I'm Paul Sutter, astrophysicist at Ohio State. And for the next half hour, your agent of the stars. Got an exciting show for you today on Space Radio where we talk about space, astronomy, astrophysics, rocketry. If it's above the Earth's atmosphere, it's in this show's universe. This show lives on listener questions. We record every Thursday at 4 p.m. Eastern. So you can leave a voicemail if you'd like to join the show. Go to spaceradioshow.com. Leave a voicemail there anytime, and we will get it on the show eventually. You can also follow along live with the recording with the Space Cadets tuning into the live streams on YouTube and Twitch. And man, they are coming in from all over the world today. We've got Amsterdam, London, UK, Atlanta, New Zealand, Stockholm, Sweden, Tucson, Arizona, Olympia, Washington, Morgantown, West Virginia, Hutto, Texas, Scavenger, Norway, I'm very sorry for mispronouncing that, and Cincinnati, Ohio, the Queen City herself. Thank you so much for tuning in, and you can join live. Check out the links at spaceradioshow.com. Seriously, folks, I've only prepped 10 minutes of show material tops, so get those questions in. Hey, Space Cadets, how's it going? Yes, I am in a different location today. Zagreb, sorry I missed you, Fran. Thank you, Nancy, for wrangling the questions. As always, how we all doing, Space Cadets? I want to know that you're okay. I want to know that you're having a good time, that life is treating you well, that life is good. It's important to me. It's important to me. As you can tell, I'm running solo today. Before I start taking calls, though, and questions, I want to share some interesting bits of news I caught recently. And by the way, I should mention, I am not in Studio A of WCBE Radio today. There is no Greg. Greg does not exist. I'm flying solo. I am in lovely Connecticut, perhaps the greatest state in this nation, but I don't know. It's kind of nice here. I'm actually out in the Northeast as a part of my book tour, floating around DC, New York, Connecticut, Massachusetts, giving talks, slinging books, talking science, doing all those wonderful things. And so if you want links to all my book tour schedule, you can go to pmsutter.com/book. You also buy autographed copies of my book from there. And let me see, today is Thursday. Tomorrow I'm going to be at the University of Maryland Observatory. Saturday I'll be at the Bridgeport Center for Science and Discovery, something like that, all day for their Space Day. And then in the evening I'll be at Caveat NYC down in Manhattan. Sunday I'll be taking a nap. And Monday I'll be at the Housing Works bookstore back in Manhattan. Wednesday I'll be in Boston, all over. Just go to pmsutter.com/book if you want to hang out at any of those events. The book tour is happening. It's real. It's alive, and it's a real thing. Speaking of something else that's a real thing, giant black holes. We have a giant black hole in the center of the Milky Way galaxy. We call it Sagittarius A star. Don't worry about the name. Sagittarius A star. It's a giant black hole, millions of times more massive than the sun. We know it's there because we can watch stuff orbiting it. We can watch stuff flowing towards it, but we don't have a picture of it because even though it's a giant black hole, it's also very, very far away. It's tens of thousands of light years away. Kind of hard to take a picture of something very, very far away. So enter the Event Horizon Telescope, or EHT, which is actually a network of radio telescopes all across the world that have been working together they took data for about a year. And the reason these radio telescopes need to be on opposite ends of the Earth is that when you have more than one telescope working together, The farther apart you can make it, the smaller the thing you can see up in space. It's as if you had a radio dish the size of the planet Earth. Of course, it's not a radio dish the size of the planet Earth, so it takes a lot longer to collect all that data. You have to wait a lot longer, which is, why it took them forever. And it's very, very tricky to actually piece together all the little bits of information, but they did after years of effort, and on April 10th, they are announcing their results, which is going to be a picture. Now, I don't know if you've ever thought of what a black hole might look like, but it's going to be black. So what you're going to see, it's going to be kind of blurry. It's going to be kind of blobby. Hey, this is our first crack at it, so give us a break. But what you're likely to see is really the gas surrounding the black hole. This is what's lighting up in radio. This is what we're actually taking a picture of. But there will be, hopefully, a missing piece. There will be a hole in the middle where no radio waves are coming from. This will be the surface of the black hole itself. And so expect it to be blurry, kind of out of focusy vibe. Don't expect it to be sharp. Don't expect to make a giant wallpaper out of it. It's not going to be that pretty. I could be wrong. But it will be so informative. And actually, I want to talk a little bit more about it before I start getting questions. Thank you, Nancy, for popping that link up there. Neil, I have not been to the Baltimore Aquarium. Sorry. I think we've got some voicemails ready to go. But Space Cadets, get your questions in. Actually, I changed my mind. See, I record this show as I feel like it, as I do. I do whatever I want to do, especially when Greg's not around. So what I'm going to do, I'm going to keep talking about black holes during the blue shift at the end of the episode. But right now, I do have some voicemails lined up and lots of Space Cadet questions lined up. So let's get right to it. And I'm going to say, Greg, play the tape, even though there is no Greg, there's no tape to play, but it feels important to maintain that tradition. So Greg, play the tape.
Hey Paul, how's it going? I've just been wondering about the unit megaparsec. I know we use it because it sounds cool and it helps us to fit in at these cool astronomy parties that everyone goes to. But hey, I'm just wondering, what does the unit actually mean? What's the definition of the unit? And why do scientists like to use it instead of light year? Cool, thanks very much.
Fantastic question. That was from Campbell, by the way, who comes into us from New Zealand. Campbell, so is asking about this word that pops up when we start talking about very, very big distances in the universe. Like when we start talking about distances between galaxies or the large scale structure of the universe itself. We get this word megaparsec. Megaparsec, and he's asking, what does it mean? And why do astronomers use that word instead of more familiar words like light year or millions of light years? So a parsec is a unit of distance, and it is defined if you look at distant stars, or any star, because all the stars are distant. If you look at distant stars, over the course of the seasons, over the course of the year, the stars will wiggle back and forth very, very minutely. And they do this because we're having a different vantage point in the solar system. So we look at from way over here on this side of the solar system, we see the stars in one position. Then we wait 6 months, we're on the opposite side of the solar system, the stars will appear to move. Just like closing your eyes, left and right eye, back and forth. There's a little wiggle there. And the parsec is short for parallel arc second, which is the distance you need to go out in space for something to wiggle by 1 arc second. 1 arc second is a tiny little distance. It's about 4 light years. It's a little less than 4 light years. I always forget the exact number. So the distance to the nearest star, Proxima Centauri, is about 4 light years. It's about 1 parsec away. And so we can go to even bigger distances. We can have tens of parsecs, hundreds of parsecs, thousands, millions of parsecs, but it gets a little bit exhausting saying millions and billions of parsecs. That's a lot of words, especially if you're an astronomer on the go. So we switch to the good old fashioned prefixes of mega and giga. So a megaparsec is 1 million parsec, which is about 4 million light years away. And we can even go even bigger, like gigaparsec, that's 1 billion parsecs, or about 4 billion light years away. And it's just a very handy, very quick notation so that you can quickly say distances without having to go through the rigmarole of saying light years and millions of light years and all that all the time. Now, I'm not exactly sure why astronomers over the decades and centuries tend to use, like if you pick up a random journal article, it will all be in parsecs and megaparsecs. Light years will hardly ever be used. But the public, you almost always uses light years and not parsecs. And I dug into a little bit. I actually dug into it when I wrote my book, Your Place in the Universe, Understanding Our Big Messy Existence, available nationwide. And I suspect no one ever said this outright. This was not a decision that someone came down with, but it appears that in the early 1800s, there was an amateur astronomer by the name of Friedrich Bessel. And Friedrich Bessel was the first person to measure the distance to a nearby star, the first person to measure a distance to any star. And he knew this was a big deal. And when he went to write about it for public consumption, like he wrote like a popular article about it because he knew it was important. He invented the word light year to describe how far away this star was. The star was 61 Cygni, by the way. It's about 10 light years away. He invented the word. Like he coined the word to describe how far away this object is. And I get the sneaking suspicion that over the decades, astronomers being snobs, as they are, that over the decades, because the word light year was invented for the purpose of public consumption, that it was like dirty to use that word. Like, ew, that's for non-scientists. We're going to have our own jargon. We're going to have our own vocabulary that only we know about. Hence the parsec and the kiloparsec and the megaparsec and the gigaparsec instead of light years and tens of thousands of light years. Now, no one officially said that. No one officially acknowledges it. That's just my own personal conspiracy theory, but I'm pretty sure I'm right. I'm Paul Sutter, and this is Space Radio. This show is brought to you by you. Go to patreon.com/pmsutter to learn how you can keep this show going, and I will see you again after the break. I really do think that's true. That astronomers are just straight up snobs about the whole thing. Oh, man. Lots of questions. I'm reading. If you ever just see me quietly reading, I'm going through and looking at the questions. Yes, Root, the observable universe is about 12 gigaparsecs across. Or no, that's the rate. Yeah, somewhere around there. It's like 90 billion light years divided by 4. So like 20-ish for the diameter. Oh, hey, Shay. Yeah, me and the dancers that Siren Modern Dance, working with them on a project discovering and exploring the nature of time. Such a fun project. There's a Kickstarter campaign, by the way, going on for Siren Modern Dance right now. So go to Kickstarter, look up Siren Modern Dance. We are funding the production of TikTok, Exploring the Nature of Time. Thank you, Shay, for reminding me. It's cool. And it's art, and it's science, and it's dance, and it's me involved, which deserves funding. Not for me, but for all the other parts. But you should go to Kickstarter and look up Siren Modern Dance. Thank you, Nancy. Boom, with the link. Man, it's so good having Nancy in your life, isn't it? All right, we've got some good Space Cadet questions, and I've got more voicemails ready to go. Welcome back, everyone. I'm Paul Sutter, and this is Space Radio. We've got more listener questions ready to go, but remember, you can join the conversation by leaving a voicemail at spaceradioshow.com or by joining the live streams, all those wonderful Space Cadets tuning in live from around the world. You can find all the links, everything you ever need to know in life that's not necessarily guaranteed at spaceradioshow.com. Now, we've got another voicemail, and Greg, who is not here because I am out on my book tour. I'm currently in Connecticut, not anywhere near Greg, and I'm sure he misses me as much as I miss him. But Greg, play the tape.
Howdy, this is Thunderduck down in Texas. My question is this. If no information is ever lost and the universe remembers everything, does that mean my refrigerator knows who took the last piece of cheese? I'm asking for a friend. Thanks, Paul.
All right, Thunderduck, who I'm pretty sure has a better radio voice than I do, but that's okay. Maybe we could do a show together sometime. Fantastic question. So his question goes back to a recent podcast episode I did and YouTube videos I did over on Ask a Spaceman about information in the universe and how information is preserved and how this is actually a challenge, this concept that information is always preserved in our universe, a challenge for things like black holes. And the specific question of who stole the cheese out of your fridge, the answer is me. I snuck in. It was last Tuesday night. I was down in the area. I was super hungry, and I have a radar for these sorts of things. So I snuck in. That's who did it. So you don't need to ask your fridge. And this concept of information and the preservation of information gets you into some pretty interesting places when you start talking about, free will and what is reality. Because in physics, everything is governed by the laws of physics, because that's kind of the point of physics. So one thing happens after another due to forces and momenta and energies and reactions, all the things we have to describe motion and exchange of motion and exchange of energies. So this means that information, like the raw information about the universe, like if you took a snapshot of the universe as it is today, everything, every single particle, molecule doing its thing, star, galaxy, person, slice of cheese, everything, then all of it evolves with time according to laws of physics. And since we know the laws of physics, kind of, sort of, but work with me here, if we know the laws of physics, then we can run it backwards too. We can look at the state right now as it is now. We can predict what the universe will be like tomorrow. And we can tell you with absolute confidence what the universe was like yesterday. This is assuming you have all the information, you accurately know all laws of physics, blah, 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 blah. But, keep going with me, like I said. So because of this, because the laws of physics tell you exactly how the universe will evolve into the future and exactly how the universe was in the past, this means that information is preserved. It gets scrambled, but it doesn't get created or destroyed. So yes, it's not necessarily that your fridge by itself remembers who stole the cheese, but the quote unquote, the universe remembers who stole the cheese. Because again, this is in this picture, in this framework, every choice I'm making, everything I'm doing is governed by the laws of physics. The laws of physics are deterministic. They tell you exactly what's going to happen next. And the laws of physics brought me into your kitchen in the middle of the night on Tuesday. The laws of physics opened up the fridge. The laws of physics stole the cheese. The laws of physics ate the cheese. The laws of physics thought it was very delicious, and the laws of physics left. Now you start asking questions about free will and all this stuff and consciousness, and I'm not getting into any of that. That's not my job. But it's in this view, it's in this framework that everything is governed by the laws of physics. So information is preserved. This is actually a problem when it comes to black holes. And I'll get into that in a little bit in the Blue Shift coming up, to talking about why we care so much about black holes. But to specifically answer Randy's question, it's not the refrigerator by itself that remembers who stole the cheese, but the universe does remember who stole the cheese. Great question, Thunderduck. And I'll get to a Space Cadet question. And while I still have a couple more minutes in this segment, I am going to take a question from the Space Cadets. Tables Frack Rakes over on Twitch is asking, would it be possible to create a binary star system from two separate stars through towing a star or some other futuristic tech? What about two binary systems and do a double binary? So lots of stars out there are binary systems. About half of all star systems in the galaxy are binary, which means about 2/3 of all stars are in a binary system or a triple system or a quadruple system. And they're asking over here on Twitch about, can we artificially make this happen? So it happens naturally. Just if you have a lot of dust and gas together at the same time, you can pop out a couple stars, 3 stars, 5 stars. I think the biggest is like 7 stars, if I remember right. But could we do this artificially? And of course, it's whenever it comes to futuristic tech or futurism or what we might be capable of in the future, I'm always of two minds about this. One mind says, okay, in the future, you can do whatever you want because you've figured out all the things and you've had enough time. After enough decades or centuries, you've cracked like all the important physics problems. You've mastered how to harness incredible, massive amounts of energy. And so, yeah, you can do whatever you want. And then the more cynical, practical side of me says, yeah, well, even with centuries of progress, are you really going to start towing stars around? Like, is that what you're going to do to amuse yourself? Or is that even possible? Or here's another way to put it. Even if it's possible, is it plausible? Like, it takes so much energy to, say, move stars around. Our sun is cruising around the galaxy at something like 200 kilometers per second. So to nudge it or move it, that's going to require a massive amount of energy. So where are you going to get that energy? Well, the most useful source of energy in the solar system itself is the sun. So you're going to have to harness solar power, or you're going to have to do a lot of fusion. And maybe after enough time of collecting energy for, I don't know, 1,000,000 years, you might get enough energy to start nudging the sun around. To what end? To what gain? So even though it's possible, yes, you could add up the energy and store the energy, it doesn't necessarily mean it's plausible. And so I wonder if we'll ever be able to do it. And I basically apply that exact same thinking to any question about futurism or future tech or what might be possible in the future, of not just asking if it's possible, because asking if it's possible is the easy question. Asking if it's plausible is a much, much more interesting question to me. Thank you, everyone, for all those amazing questions. We're almost out of time today on Space Radio, but before we go, it's time for the Blue Shift. Man, these episodes just sail by, don't they? Yes, thank you for that reminder, Nancy. So the chat scrolls by way too fast for me to catch it. So Nancy very, very helpfully collates questions so we can get in. Let me do the blue shift, and I'll hang around for a little bit longer. I'm not doing anything. I'm in a very cozy Airbnb in Connecticut. The hosts are wonderful. Got this nice guest house to myself. I'm not busy. I'm not busy. I'm Paul Sutter, and you're listening to Space Radio, and this is the Blue Shift, my opportunity to get a little bit closer to you. And I want to keep talking about black holes because, of course, there's this whole Event Horizon Telescope thing coming up next week, which is going to be very exciting, which I will definitely talk about next week. And we're interested in black holes for a lot of reasons. One is we're not exactly sure what happens to information when it falls into a black hole. Is it really destroyed inside of a black hole? Is it preserved somehow? Is it transformed and mixed up like it does everywhere else in the universe? Big kind of important question. We're also fascinated by black holes because they exist right at the boundary between gravity, our understanding of gravity, general relativity, and our understanding of the very, very small, quantum mechanics. This is a place in the universe that we can point our telescopes to and say, yes, things don't make sense here. Right here is the edge of known physics. Black holes. That's why we're absolutely fascinated by them, because the more we learn about black holes, the more we learn about gravity, the more we learn about quantum mechanics, the more we learn about the intersection between gravity and quantum mechanics, the more we learn about information, the more we actually learn about the early universe, the more we learn about physics. Black holes are just that weird, and that's why we're fascinated by them. And what the Event Horizon Telescope hopes to do, and we'll find out next week, won't we, is give us a very, very literal picture of what's happening around a black hole. So how is gas that surrounds Sagittarius A star, a giant black hole, how is it falling in? What's the shape of the event horizon? Is it spinning? Is it spinning rapidly? Is it deformed? Is it a perfect sphere? How is the gas? Is it swirling in along the plane of rotation like we think it is, or doing something else? We don't know because we've never had a picture of a black hole before. This will be our first one. And so this is a wonderful opportunity to put relativity to the test, to give us some sense of what the event horizon of a black hole actually looks like and how it actually behaves. This is wonderful. This is definitely a big deal. It's going to be hard for any other astronomy story in this year, in 2019, to top it. It's definitely, I know it's only April, but it's definitely going to be at the top of the list. So I'm excited for next week. And unfortunately, this broadcast is almost done. Thank you for joining me on this voyage of Space Radio. Once again, I'm Paul Sutter, and this show is brought to you by the Ohio State University Department of Astronomy. Learn more at astronomy.osu.edu. This show is also brought to you by you. Go to patreon.com/pmsutter to learn how you can contribute. Thanks to Greg Moebius for eventually producing this episode, Dan Michalko for being awesome, Nancy Graziano for wrangling the Space Cadets, and all the fine crew at WCBE Radio for making this show possible. We record every Thursday at 4 p.m. Eastern. Call 888. No, do not call number. Sorry. You can leave a voicemail at spaceradioshow.com. And you can also follow along on the live streams and use the exact same website for the links. And of course, thanks again, Earthlings, for listening. See you next week. And remember, science is for sharing. End transmission. So this is why I kept doing the radio or the phone numbers instead of the links. So about 3-4 weeks ago, we switched over. Instead of doing the call-in line, we did the voicemail, which the voicemails are really working out great. And I have my notes. I have a set back in studio in WCBE. I have a set of paper notes that I use for each of the segments. What I have here on the road is pictures of those notes, but I haven't done updated pictures yet since I changed. And so I keep reading the phone number and not reading the website. I'll do some Space Cat questions offline here. Benjamin Bowden is asking, if a white hole is theoretically possible, could we make Kugelbits a white hole? So the problem with white holes in general, and the reason they don't exist, is that they are unstable. If you make a white hole, then as soon as like you breathe on it, or like a little particle falls into it, as soon as anything interacts with it, like even one photon, as soon as anything interacts with it, it destabilizes and it collapses. This is due to the physics. So even though you can make a white hole, it's not going to last long at all. And so you can't really do anything useful with white holes. Timothy Blahout, even irreversible processes, information is preserved. What happens in an irreversible process is that the information is so scrambled that you are, how do I say this, extremely statistically unlikely to be able to recover the past history of that process. It doesn't mean that the information is destroyed. It just means that the information is scrambled to such an extreme degree that even though it's possible, it's gonna be a major headache. Like you might have to wait until the end of the universe before you finally figure it out. Bill is asking if primordial black holes were formed in the early high-density, high-energy environment, what causes them to grow exponentially to large size. Yeah, so the giant black hole in the center of the Milky Way is giant, obviously, but they tend to start small. Black holes start off, a few times more massive than the sun, and they get bigger a few ways. One is by just accumulating gas and dust falling in, and they just eat it. They get bigger from mergers, and as they get bigger, they become more efficient at drawing things in. They get more efficient at intersecting with other stuff. So once a black hole starts growing, it gets really big, really fast. And so this is why we tend to see only in the universe stellar-sized black holes, like the normal garden variety ones, and then the giant black holes. We don't see a lot of intermediate ones, medium-sized ones, because they grow so quickly, so fast. Larry, sorry, I don't know about Skadov thrusters at all. And what should you specialize in terms of space science? Don't worry about specialization. Just get an education in it, and then get the basics, get the framework, get the first floor, and then you specialize from